Okay. So we're going to continue talking about engineering English, and today in this session we're going to start with Unit 2. Okay,
Mhm.
that in your book that might be page 14. But before we look at the book, I'm gonna play a PowerPoint presentation for you. Okay.
Okay.
So just to briefly introduce to what the unit it's gonna be about.
Materials technology. Mhm.
So, are you now looking at the screen of the presentation?
Yeah,
Yep. Okay.
I see.
Great. So, the title of this unit it's Materials Technology. That's the title. So we can imagine a lot of stuff with when we mention the word materials. Oh, well, something that we use to build something, to create something.
Yeah.
And of course with technology. So during this unit of
Mhm.
materials technology, we have four main objectives. The first one, it's to know how to describe specific materials.
Okay.
Which materials, the one that we are accustomed as engineers to know and use in our everyday life,
Okay.
in a professional way, of course. The second objective is to categorize materials, okay, to learn how to divide them. They could be by the density, it could be by the price, it could be by the
Mhm.
usage, a lot of different divisions that we can make, filters.
Okay. Mhm.
The third objective, it's about specifying and describing properties. Properties, of course, of the materials that we use to build or create or design things or machines, instruments, etc.
You're talking
And
about the physical properties, right?
uh-huh,
Okay. Mhm.
yes. And the last objective, it's to discuss quality issues. I mean, when we talk about materials, we of course want to have a first prime quality material that lasts for years, maybe decades, and of course that is not so expensive. But there is something else that we need to take in mind, and that's it's the briefly discussed that we're going to have in here. In the first step, or yes, in the first step or level of this unit, we're going to specify on the materials, on how to describe specific materials.
Mhm.
How can we describe these ones? Well, we're going to focus on commonly used engineering materials, commonly used materials. Okay, I mean, we're not going to talk about invented science fiction materials like vibranium and stuff like that. Now,
Mhm.
we're going to talk about materials that we know we use in our machines, in our factory, in our enterprise, at my
Mhm.
work, etc. And this topic is central to all branches of engineering as a given branch of engineering uses a wide range of materials.
Mhm.
So it's for all type of engineers in here. Because of course, if you're a mechanic engineer, you use
Mhm.
materials
Yeah.
made of steel, iron, etc. And if
Yeah.
you're a construct or a structural engineer, then you use materials such as in this stone, sand,
Mhm.
bricks, and stuff like that. So all the engineers have to deal with materials.
Mhm. Mhm.
Uh-huh. So something extra that we need to take in mind, it's the context of recycling reflects the increasing importance of environmental, okay,
It's important
of environmental
consideration.
considerations, yes,
Mhm.
of engineering design. That means how can you affect or impact the environment by the things you decide to create.
Mhm.
So knowing this one, I want to talk about recently fact about a big enterprise that talking about design wants to lead an environmental or eco-friendly design. Of course, I'm talking about a big enterprise known as Apple. Mhm.
Apple like brand or in the computers or
Apple talking about brand.
yeah.
So, do you know Apple? Do you know their products?
Yeah.
iPhone, iPad,
Yeah.
iMac, MacBook Pro, MacBook Air, and stuff like that. So, this big industry yesterday had an event. I don't know if you are known of it, if you know about Apple's yesterday's event. Did you watch it or did you listen or hear something about it?
No, in this case, I watched that.
No?
I watched that. No, no.
Okay, so yesterday, Apple's event, in this case, revealed the new iPhone.
Oh, yes.
So, talking about eco-friendly and environmental design, because it's something that nowadays it's really important. How can we mix environment and engineering? Well, in this case, this is example. We have a picture of the new iPhone 12 Pro. Look at the
Okay.
price. It's from 27,000 pesos.
57,000. Okay.
The
It's more
cell phone.
expensive.
But
Okay.
look carefully, what's in the box? In the box, you got the iPhone and a lightning cable USB Type-C. But I want you to concentrate your attention in something
Okay.
really important. In the bottom, look at my spotlight. Could you please read what it says in here?
As part of our efforts to reduce environmental impact, the iPhone 12 Pro and iPhone 12 Pro Max do not include a power adapter or earpods. You can use the Apple power adapter in any heading and aids you already have you already have or purchase them separately.
Thank you. So, what is the main impact in here? This.
Well,
This is the impact. I highlighted in here.
yes.
That's the impact. The iPhone 12 Pro and iPhone 12 Pro Max do not
Include
include a
a power
power
adapter.
adapter. That means that I miss something in here. What do I
Yeah,
miss?
yeah.
Well, I miss the little square that I have in here that I connect to the light.
Yeah.
Okay, so I miss this adapter. Where is it? Well,
What's that
Apple
with the power
says
adapter?
that what? In order to reduce environmental impact, they do not include the power adapter. Neither they do not include
The
and
headphones.
the little things that you use to listen to music, the earpods.
Yes.
So no earpods, no adapter.
No.
Why? Because if they do this, they use more plastic.
Oh, okay.
So in order to reduce the environmental impact,
Impact.
they
Yes.
say, you know, we're not gonna do adapters, we're not gonna do more earpods. You can use the other iPhone's adapter
Yeah.
if you already have one iPhone. Or if
So
not,
in this case, we need another because I can purchase another brand with material with different material.
you
Yeah.
can choose to buy from another company or you can buy them with them.
Okay. Yes. Bye.
Okay, but in order to reduce the consumption, the production of this kind of plastic and reduce the environmental impact, that's a strategy.
Oh.
Okay, this was a big strategy in a globally platform that saves material. And of course, it's engineering in this part. So that's what you need to take in mind of also. Let me erase these things and let's go ahead. So that was the presentation that I want you to show.
Okay.
Let me, okay, here's the TV screen. There it is. So now that we know what we are going to work with during this unit, known as materials technology, before we begin, I want you to ask something. Which materials do you know? I want you to give me examples of materials that you use in engineering.
Well, I can use
I'm
so
gonna
much
write them.
materials. And talking about, you say plastic or rubber, steel.
Okay.
Mhm. Um,
Rubber, steel. We said the plastic, of course.
plastic, yes,
What more can you use as engineering materials?
yes. Uh,
What else? What
well,
other materials do you know?
well, so much, but in this case, aluminum,
Aluminum, yes.
copper. Uh,
Copper. What
um,
else?
more answers. There are more materials like I don't remember. I can say mm, uh, I don't remember. Acero. Uh, how can I say?
Well, it doesn't matter. We're gonna work with them in a few minutes.
Yes, inoxidable. Acero inoxidable.
Oh, you mean the
Uh,
stainless?
Stainless. Yes,
Stainless
stainless.
steel.
Stainless. Iron.
Iron,
Uh,
yes.
what is for the bronze? For bronze in Spanish
Bronze.
is bronze. Um, one more.
I think those are enough for until now.
Yes.
Later, we will know a little bit more materials that we can use during engineering. So
Yes.
another question that I have, it's about recycling.
Okay.
How do you think, well, what do you think about how does recycling affect engineering design? How does recycling
Yeah,
affect
yeah, yeah, yeah.
engineering design? What do you think
Well,
about this question?
sometimes different materials can affect recycling materials. I mean, if we use just recycling materials, it's very it's very difficult for us can use in different functions of the devices or systems is a little difficult for that. I think it's important identify the materials with several aspects. In this case, using the function of the material, we know we should to know different functions and what more and useful. I mean, talking about description, properties, physical properties, and, and I don't know, one more, so much different objectives for the system to use this class of materials. No, I think it's
Yes.
important.
Okay, that's
But
great.
see, I think it can affect a little bit the functions. Talking about uh, also for costs is
Mhm.
important. In the cost is important.
Okay, that's great. Yes, of course you have to think a lot in the quality of the material that you're going to use and the kind of specifications and actions that the device is supposed to do, and that the material that you want to use has the ability to
Yeah,
do what you want to do as a
yeah,
device. Yes, okay, great. So, of course, engineers need to design in recycling. I mean, to plan for how assemblies will be disposed. Because when we talk about recycled materials, we need to think also about assemblies. What, oh, yes, actually, what can we combine in order to have a superior quality material? Mhm.
Well,
The main ideas in
in,
here.
in, in one material, talking about one material in specific, or
No, it's just like just a comment. I mean, that's the main idea of the
uh,
design in recycling.
mhm.
Mhm. Great. So let's just start talking a little bit more about this thing. Let me close this in here and let me make a zoom. I think like this, it's enough.
Okay.
So talking about describing materials, I want you to look at the 4 steps that we have in here below. We have breaking up ships, demolishing buildings, recycling electronics, and scrapping
Scrapping
cars.
cars.
Hmm?
Mm.
So these, let's see, ideas of recycling. Let's think about the pros and cons. That mean the benefits and the problems of recycling. These are 4 examples in where can we or how can we do recycling. So that's what I want you to think now. Okay,
Mhm, mhm.
about breaking ships, demolishing buildings, recycling electronics, and scrapping cars. Mhm.
Okay. Well,
I
then
want you to
scrap.
think,
Mhm.
what are the benefits of these 4 ways of recycling? You can go one by one.
Okay. Well, I want to start with scrapping cards. The scrapping cards is for us. I think talking about social with the social people is important, but I think the benefit is so much because we don't have uh, a big population of cars on the city or a city, and it's important also for reduce reduce uh, the quantity uh, of traffic in the avenues or
Mhm.
around the city. I think is a good it's common, you know, for our city, you know.
Yes. Okay.
And
So what?
recycling,
Uh-huh.
okay, okay.
No, just
Uh,
continue.
Recycling electronics is the same way. I mean, I think is important reduce the materials. Talking about electronics or materials with devices. I think explosive, or I think an explosive or attack, chemical attack to the humans, important in for all devices that
Mhm.
people buy in the stores or malls. It's I think for the environment is specific reduce this class of materials too. No?
Okay, okay. And that's what
And
also about the scrapping cars?
scrapping cars. Well, talking about no benefits is good or no, it's good produce and to and make scrapping cars is
Mhm.
good. I think it's a good idea to keep the scrapping cars in the city now.
Okay. Yeah, so I want to talk a little bit about these four different ideas. Of course, breaking up ships, it's a good way to recycle material. Demolition buildings, of course, recycling electronics, I think that's one of the biggest recycling ideas in here. Because
Yes.
we every year dispose millions of cell phones, microwaves, hair dryers, and stuff like that. And scrapping cars, I think it's also a good way to recycle because I mean, those cars, anyone is gonna use them anymore, so
Mhm.
scrap them. So talking about this one, let me just write in here a little for I think like this, and decide about these four ideas. Okay, talking about breaking up
Chips.
ships.
Uh-huh.
Yeah, breaking up ships like this. This is a good point because we can obtain large amounts of steel.
Of
You
steel.
know, the ships are made of steel. So
Mhm.
if we break them up, then we can get recycled steel that, of course, we can, this steel can be recovered and recycled into an other devices or items. Mhm. The only problem is that the main pollutants are the fuel oil from the tanks. The oil from the tanks of these big ships is actually one of the problems that they need to deal with.
Mhm.
The other idea about demolishing, let me write it down here, demolition buildings.
Okay.
Now, what about this one? Of course, if we turn down some buildings, what we can recycle is structural.
Mhm.
I mean, the structure still can be recycled, of course. We can build more things. Oh, we can build more things with these ones. The concrete can be crushed and reused. I mean, it's concrete. You can use it again, but only
Mhm.
you
The
first need to
concrete
crush it.
is can recycle. The
Yeah.
concrete. Oh yeah. Mhm.
Yes, but first you need to crush it a little bit, a lot.
Uh-huh.
For example, the concrete, you can still use it for asphalt, for road surfacing, okay? You can also recycle the copper from the electrical wires of the building,
Mhm.
okay? There are a lot of things that you can do uh, to recycle, of course. If we talk about now recycling electronics, I want you to think of what can we recycle in an electronic. Well, we can get out the heavy metals. What do I mean with heavy metals? Oh, it's heavy, no heavy. Heavy metals
Yes.
in cell phones, microwaves, for example, lead,
Mhm.
aluminum, the cadmium also.
Mhm.
It's cadmium, yeah.
Titanium.
Yeah.
Titanium.
Titanium and chromium.
Mhm.
These are materials, heavy metals that are potential pollutants
Yes.
and can be also, let me write it in here, they're potential
Potential.
pollutants. Okay,
Mhm.
they can pollute a lot. And at the same time as pollutants, they also are like they can be recovered,
Okay.
can also be recovered, and you
Recover.
can recycle them.
Mhm.
And the last one, talking about scrapping cars, cars that anyone else is going to use in no more time. What can we get of the cars? Any idea?
Scrapping. It's the same. We can recover the steel,
Yes, a lot of metal.
a lot of metals, steel,
A lot of
plastic.
metal, steel.
plastic.
Plastic, yes, why not?
Mhm.
All these
And
materials
yeah,
can be recycled.
yes,
Yes.
glass is good in
And we
this.
can also recycle the intact parts.
The parts, yes.
The intact parts can be recovered,
Mhm.
refurbished in this case, and
Mhm.
resold to anyone that needs a piece of car.
Mhm.
That's the main idea. The only
Yes.
thing that sometimes we might be difficult, it's the brake fluid, the battery acid, because they are pollutants.
No,
So
yes.
they need to be disposed carefully.
Exactly.
But these are like the main ideas in what
Uh-huh.
can you get recycle of each thing.
Mm.
Great.
Okay,
And
okay.
before I just continue, let's mention a little bit more materials that I
Mhm.
for well that I told you that we were supposed to mention in here. So, in the used materials of engineering, you mentioned, could you please read the materials?
Uh, More materials are.
Oh no, the ones that we have now.
No, it's okay. It's okay.
Mhm.
Um,
You mentioned rubber, steel, plastic,
Plastic,
aluminum,
aluminum, copper,
copper.
stainless steel, iron, bronze,
We can
mhm,
also have glass,
glass, and
lead, yes,
mhm,
rubber. Oh no, you mentioned rubber. Stainless,
chromium,
stainless steel, chromium, yes,
chromium,
timber,
timber,
hardwood, softwood, and zinc. These are the materials that are often recycled. And of course that,
recycle.
and of course that we might use inside the engineering design. Mhm. May I erase this?
Yes, no problem.
So let's continue with the next part of it. So in exercise 2, you have to read the following web page. It's about recycled materials. It's a web page. And you have to complete the missing headlines, okay, using the words in the box. So you can see that they have a headline, but they're not complete. We have materials as options. We have aluminum, copper, glass, plastic, rubber, steel, and timber. Do you know the meaning of all these materials?
Well, now I don't remember timber. I don't.
Timber, it's wood.
Wood.
Mhm.
Okay. It's a
It's wood.
synonym of wood. A synonym of wood.
Yes, it's well, timber. It's the wood that it's made as structures like rectangles
Um,
and stuff like that.
uh,
Like the ones that the construction workers use.
uh-huh.
You know that when they build a ceiling, they put some timbers as
Mm.
base.
Okay.
Well, that's the main idea, the timber.
Okay. But this is the same to wood.
Yes,
Okay.
it's. I mean, at least it's wood.
Mhm.
I mean, that's the main idea. So this web page about recycled materials, it's let's see, describing.
Mhm.
Okay, it's describing the material. You need to think about the description of the material, and according to the same description, you're going to decide which material they are talking about.
Mhm.
Let's look at example. Let me make another more zoom. And it says, look at example number 1. It says, a scrap can be sorted easily using magnetism. If the metal is galvanized, coated with zinc, the zinc is fully recyclable. If it's stainless steel, other metals mixed with iron, such as chromium and nickel, can also be recovered and recycled. So as they're talking about the scrapping, they're talking about cars, they're made of steel. That's why they use steel. So you need to think about the description.
Okay. So number 2.
Yes, please read it.
Sorting is critical as there are key differences between the clear and color materials used in bottles and jars, and the high-grade materials used in engineering applications, which contains trace of metals, right?
Okay, thank you.
So if I see that class of materials, it can be the difference between the clear and color material. Okay, color materials. The glass because yes, because it's used in engineering application.
Bottles and jars.
Yes, bottles and jars.
Excellent. The third one says, scarcity makes recycling especially desirable and justifies the cost of removing insulation from electric wires, which are a major source of scrap. Poor metal can also be recovered from alloys derived from it, notably brass, which also contains quantities of zinc and often lead, and bronze, which contains tin.
Okay.
So what material do you think they're talking about in here?
It can be two materials, but when you say that
If you continue talking about a kind of metal and insulation.
Yes, insulation from electric wires, it can be copper.
Copper, yes.
Copper, okay.
Excellent. Could you please read the next one?
Okay, the following is, the cost of melting down existing metal is significantly cheaper than the energy-intensive process of electrolysis, which is required to extract new metal from one, right? Sorry.
Metal from ore.
From ore. Ore. Okay.
Yeah.
New metal.
Ore, that means mineral.
So in this case, it's melted down system metal. Okay. Process electrolytes. Okay. Maybe it is aluminum. No.
Aluminum. Yes.
Aluminum. Yes.
Yes. Aluminum.
Aluminum. Glass.
Number 5 said, hardwood and softwood can be reused. However, the frequent need to remove ironmongery and saw or plane off damaged edges can make the process costly. So what about this material?
It's hardwood. Hardwood is like timber, no?
Yes.
Hardwood, like timber.
Then the answer is timber.
Okay.
Number 6, please.
Number 6 is tires are the primary source of recycled material. This can be reused wool in certain applications. They can also be ground into crumbs, which have varied uses. In this case, I'm talking about tires. It can be plastic or rubber, sorry.
Rubber, yes.
Yes, sorry.
Rubber.
Okay, the next is an obstacle to recycling is the need to sort waste carefully. While some types can be melted down for reuse, many cannot or result in low-grade material. And the last is like plastic.
Plastic, yes. Great. So, in this part, they are describing different materials with different usages according to the idea of the same material. Now, something that I want to defer, it's the word aluminum, okay?
Yeah.
I want you to show you a difference. We sometimes say aluminum,
Aluminum.
like this, but sometimes we also say aluminum
Mhm.
with I, aluminum, okay? What's the difference? Well, aluminum, it's American English, and aluminum, it's
British.
British English.
Mhm.
That's the only
Aluminum.
difference,
Aluminum.
okay?
Okay.
Aluminum or aluminum.
Mhm. Good.
So for you to know the difference,
Mhm. That's good.
Great. Now, let me erase this thing in here. And let's make a little bit more of vocabulary as
Mhm.
an extension activity, okay?
Mhm.
So for example, let me write down here just 3 more examples in here. So we can have another meaning from the terms, like for example, magnetism.
Mhm.
Magnetism, okay? So what is magnetism? Force of attraction.
Mhm. Electromagnetic.
Okay, force of attraction. That's another example. You also mentioned chromium as another material. Chromium and nickel. Chromium and nickel are metals added to steel. That means they're additives, son aditivos.
Okay.
But why? Why do we have chromium and nickel to steel? Well, we
Exactly.
create, what do you think we create if we add them? ¿Qué pasa si mezclamos el metal con el cromio y el níquel? ¿Qué creamos?
Fundición o
No?
stainless. No.
Stainless steel. If we combine steel with chromium and nickel, we create stainless steel. Okay.
Okay.
We also have bronze. That what is bronze? It's an alloy. Okay, you know what an alloy is?
Alloys, copper and steel.
And
No,
tin.
tin and tin.
Alloy, it's the union, la mezcla,
Yes.
ajá, la aleación
Mhm.
of copper and tin.
Okay.
And other word that you have to know here, que verás aquí, es ore. What is ore? It's a mineral from which metal is extracted. It's
Okay.
like the rock. Where you got the material in here, okay?
Similar to the silver, no? In this.
And difference between soft and hardwood. Hardwood comes, it's timber. I mean, it's timber from deciduous trees. Okay.
Okay.
Meanwhile, softwood,
Softwood.
it's timber. It's timber, but not from deciduous tree, but from pine trees. That's the difference.
Okay. The trace of one spine and another is trace. It's
Deciduous.
different.
That's the only difference. Great. Tell me when I can erase it.
Okay, yes, it's okay.
Yes, okay. So knowing this one, I want you to turn page 15 and look at exercise letter B. Could you please read the instructions?
Yep. Letter B is match the materials from the web page 1.8 in exercise 2 to the definitions AH.
Thank you. So we have in here numbers and letters, and the idea is that you're going to combine, well, to match the definition of the material. For example, number 1 says, what is a stainless steel? Oh, stainless steel, it's a type of steel not needing a protective coating as it doesn't rust. That means no se oxida. That's what is stainless steel. What about zinc?
Well, if you say, well,
About zinc.
let me go, let me check. Zinc. Maybe is the predominant metal in steel? No.
Of which one?
Letter B.
The predominant metal in steel, the zinc, you said.
Is or...
No, I'd rather use this one. Let me make a color red, yes. Zinc, it's a metal used to make brass. It's letter A.
Okay.
To make brass, and it's galvanized coating on the steel.
Okay. So number 3 is iron. So
yes.
in this case is the predominant
metal in the steel. Yes.
Sorry.
No, it doesn't matter. What about bronze?
Bronze.
What did we say? It was bronze.
Okay. You say that bronze is like alloy made from copper and tin.
An alloy made from copper and tin. Yes. What about lead? What's lead?
Okay, lead. No. Well, in this case, I think lead is a dense poisonous metal.
Exactly. Lead is a dense poisonous metal. In Spanish, lead is plomo.
Okay.
Now, what about hardwood?
Well, in this case, hardwood is, you say that it is timber from deciduous trees?
Deciduous tree, letter H. Excellent.
Softwood is timber from pine trees. And or
yes, or
like rocks from which metals can be extracted.
Rocks from which metals can be extracted. Yes.
Okay.
Exactly.
Because you told me before the exercise, the past exercise.
It's similar, yes.
Yes.
I just want to assure a pronunciation activity, okay? Just for you to assure the pronunciation of this material. So repeat with me.
Okay.
Ore.
Stainless.
Galvanized. Wood. Food. Food.
Okay.
Zinc. Chromium. Nickel. Well. From. Lead. Excellent. Okay. Great. That's for us to share the pronunciation.
That's good.
And now let's look at exercise 6, where you have to complete the following sentences using just 3 words, prepositions from,
Yes.
with, or
And
of.
so-
Okay?
okay.
With, from, or of. So let's look at this sentence. And of course, you need to know the differences between from, with, and of. Mhm.
The difference is when I can connect or add, I mean, connect the sentence with other property or other word. This is
Okay.
like a connectors.
Yes, there are connectors,
Mm-mm.
but we just
Connectors.
know to know the differences between from, with, and of. Mhm.
Yes, yes, I know.
Okay,
Okay.
excellent. So, of course, each of them have a property on the usages of them. Okay,
Yep.
that's what you need to know to lead of it. Okay,
Uh-huh.
that's the main idea. So,
Okay.
look at number 1. It says bronze contains significant amounts of copper.
Mm-hmm.
Significant amounts of copper.
Of course.
That means
Bronze.
because it's like a possessive. Okay,
Yeah, it's possessive. Yes.
it possesses copper.
Mhm.
Number 2. Galvanized steel is steel coated zinc
We sing, no?
with zinc. Exactly.
You
Why?
sing.
Because you use that material in this part. So let me write in here with. With. 3. Steel is an alloy derived
Still is an alloy derived from iron.
from iron. Exactly.
Number 4 is
Mhm.
pure metals can usually be recovered from alloys.
From alloys, yes.
To produce stainless steel, iron is mixed, is mixed, no, with other metals.
It will be
Correct.
with others, yes.
So stainless, the number 6 is stainless steel contains quantities of chromium and nickel.
Mhm.
And the number 7 is glass tableware contains traces. Contains traces of metal such as
Of
lead.
metal. Uh-huh.
Mhm. And the last
And
is
such the
when,
last one.
so the last is when new metals is extracted. Okay, from ore or the cost can be high.
Straight from ore, exactly. The cost can be higher for.
Exactly.
Yes. Great, excellent. I think this wasn't difficult.
Yeah.
Let me erase these things in here. Great. Now, it says ask and answer questions about different materials using the phrases. Look at the phrases. I just want you to look at the phrases. It says can be
Beers.
recycled. So you need to apply a material. Can steel be recycled? Oh, yes, it can be.
Can Cooper be
Or the question,
recycled?
what made from. That means, what's the steel made from? Oh, it's a steel from copper and zinc. Like the origins. Then you have where does come from? That means the place of origin. Where does the steel come from? Oh, from an ore. Okay.
Okay.
So that's the main idea of this activity here.
Good.
Great. So let's go a little bit down. You have a photo of a lady. Look at the lady.
Yep.
Her name is Irina.
Okay.
Irina is an ecological advisor.
Yes.
So, Irina, as an ecological advisor, is talking to a group of engineers on a training course about environmentally friendly design. Remember that when, as engineers, you sometimes need to design prototypes of machines, devices, systems, programs, etc. But you need to take in mind, of course, the environmental friendly. That means you're eco-friendly. I don't know, is your industry eco-friendly? Do you know?
Well, ecological people or?
The enterprise as itself, Komatsu, is it an eco-friendly enterprise?
Yes, eco-friendly.
Yes.
Yep.
Why?
Yeah.
How do you know it's ecological or eco-friendly enterprise?
We have so much speech. If you have, well, in this case, we have a speech in the company that we can use, I don't know, reduce recycling and reduce recycling, and you should reduce and recycle materials like paper. Well, I think is that eco-friendly, when you talk about like emissions or what ideas for protect the environment, no? To environment. Is that?
Okay. Yes. Yeah, so I mean, just as a extra point of view, environmental friendly design, it's the designing with environmental protection in mind. So for example, recycling, energy efficient, avoiding pollution, etc.
Okay. Okay.
That's like the main idea of the pollution by itself. Great. So you're going to listen to an extract from the talk between Irina and the training course, okay?
Okay.
Irina mentions that a product faces three: the pre-use, the in-use, and the post-use, okay?
Okay.
So I want you to listen carefully and compare your ideas with Irina says, okay? I want you to pay attention also in how did she give an example, cómo ella dio un ejemplo. Okay, so let me play the audio and let's just listen, of course, the extracts of this conversation, okay?
Okay.
Let me find this, I think it's this one. Let me listen.
2.1.
Yes, that one.
The only way to assess the environmental impact of a given material properly is to carry out an environmental audit and analyze the total impact of that material on the environment. I emphasize total impact because it's all too easy to judge materials and products on single aspects of their ecological impact. As an example, if we compare traditional and energy-saving light bulbs, it's tempting to say energy-saving ones are better because they consume less energy. In fact, that's only part of the picture. That's just the in-use phase. You also need to consider the pre-use phase. In other words, the environmental impact of mining the materials used to make the bulbs, of transporting those materials to the factory, of manufacturing them, etc. Then there's the post-use phase. How easy is it to recycle spent bulbs? And when you start to consider all of these factors, suddenly the comparison between classic bulbs and their energy-saving equivalents becomes much less clear-cut. Some of the materials used in energy-saving lights are problematic from an environmental standpoint, both in terms of acquiring them and recycling them. So the point is, it's essential to look at the whole picture, and doing that can be quite a complex task, as we'll see later on in.
Okay. So what do you think about this? About what Irina mentioned about the phases of the, let's see, the product phases?
Well, she emphasized about total impact to our environment, and,
Yes.
and she analyzed that impact through materials, and maybe talk maybe talk to compare the energy or
So, well, that was example. She gave the example.
Well, maybe.
So I think we can write. I don't know if you have a space there, or you can write it in another part. But let's see the answer of the letter B, what example that she used to illustrate the main point was the main point, as you mentioned, yes, the main point that Irina makes important.
Okay.
Is that
total impact.
Yes, that it's important to consider the total environmental impact of a product. What do I mean with the impact, total impact of a product? That means the three phases.
Yes.
That means we need to include the producing of the product. That means the pre-use. We also need to take in mind using the using it phase, that is the in-use phase actually. And finally, recycling it. I mean, would it be possible for the item to be recycled? That means the post-use. And she gives an example. Well, she gives the example
with
of what?
Bulbs.
Exactly.
With the bulbs.
The example of an energy saving light bulb. I mean, they mentioned if you compare a 5 years, 10 years ago light bulb with nowadays, I mean, now we use LED light bulbs that they produce even more light with low energy. Meanwhile, the last 10 years ago light bulbs, they consume a lot of energy to use like 60 watts or something. So this would be the main point, the answer of the letter B. Mhm. Yes.
Mhm. Okay.
Okay. I know if I can erase it or you already write it down.
No, no problem. Yes.
Yes, may I erase it?
Yeah.
Okay, let me erase it.
Yeah. Please.
Okay. So well, that's the main point of view during this part actually. Okay. And that was the last exercise that we were supposed to answer during this session. So let me just stop recording and we quite finish with it.